Well, I think there's some interesting problems and challenges we face, which even with the amazing scale of compute we have at the moment really can't be tackled. So if you take about challenges around things like global warming and things around drug discovery and new medicines, there are computational parts of solving those problems which are really just beyond what we have with classical IT at the moment. And for that reason, because quantum computing potentially offers a chance to address those problems, is something that we're really interested in. What industries are there where very large amounts of compute are required to solve meaningful problems? And when you take it that lens, you can think about things such as materials science, you can think about chemistry and biotechnology, you can certainly think about financial services and high-scale data and big data problems, and you can also think about what are the limits and what we do with around machine learning and artificial intelligence. So really any of those particular areas where there's a potential to solve an even greater scale of kind of computational numerical problems using quantum computing versus what we can now with the vast high-performance compute capabilities we have. It will impact on many of those industries simply because of the availability of this new kind of computational scale. So why are we thinking about a new programming language or approach for this? Well, the thing to again, take a step back. What we're really thinking about is the full stack, right, for quantum computing. So at the bottom level, down near absolute zero, we're going to have the cryogenics and the dilution refrigerators to run the qubits at close to absolute zero. And above that, we're going to have a really challenging to develop but cryogenic computer somewhere around 4 Kelvin, which is a classical computer, which actually then runs the quantum computer underneath it. And on top of that, of course, they're going to build the software and the stack of software which enables you to run meaningful programs on this. And so clearly we have to adapt some of our existing kind of approaches to writing software and algorithms to work on this new kind of full stack which we're developing. So as part of that, we've produced a new language. It's very, very similar. It's derived from languages like C# and F#. It's integrated in with Visual Studio, and it's a starting point for developers to start thinking about how they think about writing software and applications for this full stack solution.